Hello everyone, welcome back to Math with Allison. Today we're working in an integration series, so we're talking about partial fraction decomposition and specifically irreducible quadratic form. Alrighty, so let's go ahead and dive into it. First we have simple factors. So when we have a simple factor, so x minus 2, x plus 2, x minus 4, there's no repeats of them, they're very unique. We just split them up, each with their own individual scalar with their own fraction, right? Those ones we do nothing special with. When there are repeated factors, so we can see on the left side x plus 3 is squared, then what we have to do is we write one out normally, but then we take our second one and we square it. And then this other factor where we have the x minus 2, it just gets its own over here, right? There's another form that we could work with, and it's when we cannot reduce the denominator. So here's an example. Here we have a factored x, but notice here we have x squared plus 2x plus 1. Now that quadratic form is not factorable. And so notice here what we do a over x, right? That's totally normal. Same thing with simple factors. But we do something special with that irreducible quadratic form. And what we do is we take a polynomial of 1 degree less. So this is a degree 2 polynomial, x squared. So I'm going to write a new polynomial above it, bx plus c. So let's go ahead and try to simplify this out and see what happens, right? So for example, if that was like an x cubed, then we would have to have bx squared plus cx plus d. So we take a new quadratic of 1 degree less, and that's how we write it out. But remember, it has to be irreducible. So let's go ahead and try to simplify this. Remember, our first step is to multiply by the entire denominator. So when we do that on the left side, we get that the entire denominator cancels out. We have on a that x cancels out, so we have x squared plus 2x plus 2. And then that bx plus c, the quadratic cancels out, and we're just left with that x. So let's go ahead and simplify this. If I multiply that a through, I get ax squared plus 2ax plus 2a. And then over here, we get plus bx squared plus cx. So now let's go ahead and combine common terms. We're going to combine our x squared. So we have a plus bx squared. And let's combine our x's, 2a plus c times x. And then our scalars, it looks like we just have a 2a. So notice on the left side, we do not have any x squareds. So here we have 0x squared minus x plus 1. Now, since these two are equal to each other, we know that they have to be exactly the same on both sides. So our x squareds have to be the same. So a plus b has to be 0. Our x's have to be exactly the same as well. And then our scalars also have to be exactly the same. So let's go ahead and set up our three equations. So now you can choose whichever one looks easiest to solve for. I see on that purple equation, I can solve for a. So I get a is equal to 1/2. So here you can just plug it in left to right. I know that 2 times our a value, which we got to be 1/2, and then plus c is equal to -1. So that's equal to 1 plus c is equal to -1. Subtracting 1 from both sides, I get c is equal to -2. So our last guy to solve for is going to be that b. So here we get 1/2, which is our a value, plus b is equal to 0. So that tells us our b is equal to -1/2. So now we have our partial fraction decomposition. So we have a over x, so that's going to be 1/2 over x, plus b, which is -1/2 x, plus c, which is actually -2, so that's just going to be -2, and then divided by that entire quadratic, x squared plus 2x plus 2. So that's what happens when you have a polynomial that you can't reduce all the way, right? So let's go ahead and do our first problem in which we're going to go ahead and try to integrate this. So we already know what this is equal to. I can pull out a -1 out of that second, so I get 1/2 x, and that's going to be plus 2, divided by x squared plus 2x plus 2 dx. So to make this a bit nicer to look at, I'm going to factor out a scalar of 1/2 out of everything. So we get 1 over x minus, when I pull out a 1/2 here, I get x plus 4 now, right? And then that's going to be x squared plus 2x plus 2. So the question is, how are we going to simplify this? Well, we know how to integrate 1 over x dx, right? That's just going to be natural log of x, so that's not really our issue. Our issue is this other one over here. So looking at the second integral, I want to use u substitution. So let's say theoretically I set u equal to x squared plus 2x plus 2, right, the denominator. Then my du would be equal to 2x plus 2. The issue is that in the numerator, I don't have a 2x plus 2, but we can make a 2x plus 2. What would happen is I have to multiply the numerator by 2 in order to get the 2x, but that means I have to multiply on the outside by 1/2 because I can't just magically multiply by 2, right? So on the outside, I'm going to multiply by 1/2. And so this, if I distribute this out in the numerator, we have 2x plus 8, right? 2x plus 8. but I only want plus 2. So let's go and rewrite that plus 8 as plus 2 plus 6, right? That's what 8 is equal to. So what we could do right here, I'll go ahead and write it out actually. Integral of 1 over x, we'll just go ahead and do that real quick. And now we have minus 1/4, and we're going to separate this into two integrals. So first we have 2x plus 2 divided by that denominator, x squared plus 2x plus 2 dx, and then don't forget we still have that minus 1/4 on the outside, but now I have that remaining 6 in the numerator, right? But we can split that up into two separate fractions. So now I can actually use substitution on that first integral, but what are we going to do with the second integral? Well, what we're actually going to go ahead and do is complete the square. So here what I'm going to do is I'm going to add 1, but I can't magically add 1, so I also have to subtract 1, and then we have that remaining plus 2. So the purpose of doing this is notice with these guys right here, this is a perfect square. That's going to be x plus 1 quantity squared. So I can rewrite that as x plus 1 quantity squared, and then minus 1 plus 2, that's just going to be equal to plus 1. And notice that's going to be in the form of arctangent, right? We have x plus 1 quantity squared. So now we have everything lined up so that way we can integrate it really nicely. So let's go ahead and do that. We have 1/2 natural log of x minus 1/4. And here we set u equal to the denominator, and we have du in the numerator. So that's just going to be 1 over u du. And then minus, if you wanted, you could bring that 6 to the front. So we get 6 over 4. And that's going to be arctangent or inverse tangent, whatever you prefer, of x plus 1. That's what's being squared, divided by the square root of our a term. But that's just going to be 1. So that's going to work out very nicely, plus some constant c. We are not done here. We got to keep going. Natural log of x minus, that's going to be 1/4 natural log of u. But I'm going to fill in what u is real quick. X squared plus 2x plus 2. Minus 6 over 4, which is equal to 3/2 inverse tangent of x plus 1 plus c. And that right there is our solution. So here I got another one for us. We have x minus 2 times the irreducible form x squared minus 2x plus 3. So our first step is to do partial fraction decomposition. So I'll go ahead and set it up. So doing this, we have our normal simple factor, x minus 2. And now in the denominator, we're going to have the irreducible form, x squared minus 2x plus 3. And so we have to have a polynomial of 1 degree less, so bx plus c. So let's go ahead and do this. We're going to multiply the entire denominator. So we get 7x squared minus 13x plus 13 is equal to a times our quadratic, x squared minus 2x plus 3, plus, and then we have that bx plus c just multiplied by the simple factor x minus 2. So now we're going to just, math it out. Now that we have it multiplied out, we're going to go ahead and combine some common terms. So let's do our x squareds first. I see an a plus b, any c's? Nope. Okay, so that's our x squared. Let's combine our x's. Negative 2a, and then minus 2b, any, oh yeah, there's a c. That's our x. And then our scalars, 3a, and then no b, so just minus 2c. So let's go and set up our equations. First, we have our x squareds need to equal 7. We have negative 13 x's, and then finally, our scalars have to be equal to 13, right? So let's go and write out our three equations. Okay, and here we're just going to have to plug and chug. So I guess I'll just go ahead and solve for a. A is equal to 7 minus b. With the pink equations, we need a, b, and c, so I'll go over to the purples. 3 times a, which we got to be 7 minus b, minus 2c is equal to 13. So let's go ahead and solve for c in terms of b. That way we have a in terms of b is already in terms of b, and c in terms of b. So that's going to be 21 minus 3b, minus 2c is equal to 13. Subtracting 21 from both sides, we get negative 3b minus 2c is equal to negative 8. And then adding over that 3b, negative 2c equals negative 8 plus 3b. And dividing by negative 2, we get c is equal to positive 4 minus 3/2 b. So now we have a and c both in terms of b, so let's replace it here. Negative 2 multiplied by a, which is equal to 7 minus b. Minus 2b, that can just stay the same. And then plus c, which we got 4 minus 3/2 b. And this whole thing is equal to negative 13. Now we get to solve for b. So let's multiply this out. Negative 14, that's going to be plus 2b minus 2b. Oh, that cancels out. That's nice. Plus 4 minus 3 halves b is equal to negative 13. Those cancel out nicely. So we get negative 14 plus 4, that's negative 10. And then minus that 3 halves b is equal to negative 13. So let's add 10. We get negative 3 halves b is equal to negative 3. I'll multiply both sides by 2. Negative 3b is equal to negative 6. And dividing by negative 3, we get b is equal to positive 2. So that's a nice number. Now we can just use that to find c. C is equal to 4 minus 3 halves multiplied by 2. So we get c is going to equal 4 minus 3, which is equal to 1. Oh, that's also very nice. Let's see if a is going to be a nice number. A is equal to 7 minus b, which is equal to 2. So a is going to be equal to 5. So now that we found what the factored form is going to be, let's go ahead and write it in our integral. So we have the integral of a over x minus 2. So 5 over x minus 2, the bad 2, plus bx plus c. So it's going to be 2x plus 1. That whole thing divided by our quadratic, x squared minus 2x plus 3 dx. So we know how to integrate that first one. So that's just going to be 5 times natural log of x minus 2 plus, and now let's rewrite this. So we have 2x plus 1 divided by the quadratic. And just like last time, we want to use u substitution. We want u is equal to x squared minus 2x plus 3. So then my du is going to be equal to, that's going to be 2x minus 2 dx. We have the 2x, but we have plus 1. So how can I rewrite plus 1? Well, I can rewrite it with minus 2 plus 3. So now notice here we have our 2x minus 2, which is exactly what we want. So now we need to split this into two separate integrals. So in our first integral, we have the 2x minus 2 over that whole thing, which will turn into our 1 over u du, right? But then we have that plus, and that's going to be the integral of 3 over the quadratic. So let's go ahead and complete the square in the denominator. So to complete the square, don't forget that plus 3. I'm going to add 1, but I can't randomly add 1, so I also have to subtract 1, and then there's our plus 3. So notice that these terms right here is going to be the perfect square of x minus 1. So I'll go ahead and rewrite that. And then minus 1 plus 3 is going to be equal to 2. So it's going to be plus 2. And notice here we have the form of arctangent or inverse tangent, right? So let's go ahead and do this thing. 5 natural log of x minus 2 plus, that's going to be natural log of u, which we can just plug u right in. X squared minus 2x plus 3. That's going to be 3, which is our scalar right here, divided by the square root of 2, right? Because this right here is our a squared, which is going to be the square root of 2 squared, times inverse tangent of our x term, which is squared. So that's going to be x minus 1 divided by our a term plus c. And that right there is our final solution. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.